Today we can do one more example. In last class we discussed Can you see the whiteboard? So in last class we discussed about conversion of NFA to DFA. I hope everyone got the idea how we can convert. So first you just need to design the NFA if your question comes like that. Okay, sometimes it also happens like NFA is already given. You just need to design the equivalent DFA. So for that, what you have to do first, make the transition table of NFA. Then we design the transition table for the equivalent DFA. And from the table, we just draw it. Was it okay for everyone? Do you want another example? Here. So no need to explain again, I guess. I can give you class task. You can do it yourself. And I will say what task. What about others? In class, most of the time only Dullard and Norway. What happened to the others? I don't know whether you guys are following or not, whether you guys are understanding or not. 18 से तो क्लास होने वाला है ऑफलाइन क्लास अब ऐसे नहीं चलेगा so you first try see this try the all types of DFA we used earlier. For example, NFA or students. That starts with 0. Second one you can try. I'm simply giving you NFA. This is initial state. So try for this two. Okay, convert NFA to DFA. One is NFA for strings starting with 0. Another one is just directly giving you the NFA. Just write it down. Done. और होमवर्क के सिर्फ दुलार एंड रोजी थे सबमिट करते हैं बाकी लोग का क्या हुआ व्हाट हैपेंड टू अदर्स let me know your problems okay others also whether you are finding this subject difficult whether you want extra classes if I'm going fast I'm going slow if you don't tell me I know this subject for like practical implementation there is uh, it's honestly there is no use for your like future for job related purpose and all. But if you give competitive exams for government job, this particular subject holds a good portion of marks. Okay? And if you understand this subject, it is very easy. If you don't, then it is going to be a very difficult subject. So don't just neglect it because this subject is all about theory and maybe there is no practical use right now in current scenario, but based on this subject only, they build the computers function. Okay, done. So we will see Epsilon NFA this time. So what is an Epsilon NFA? Epsilon NFA is nothing but NFA that accepts null modes. Okay, that means it can accept a null mode and go to a different state without consuming any input alphabet. Using null mode, it can consume to different state without consuming input signals. So, means with the help of formal definition, it is just like your NFA. That means it is also a 5 tuples one with input symbols Q naught, sigma, sorry, Q, Q naught, sigma, final state, and your transition function. Okay. Everything is same. Only difference is that the transition state. So transition state for your epsilon NFA is Q to sigma union epsilon 2 power x. Normal NFA, there is no this union part. Okay. But in epsilon NFA, there is this union part. This is the only difference. That means what? In normal NFA, or even in DFA, we know that from one state it can transit to another state by consuming one input symbol or two input symbol. It can go to different states. Okay, in NFA also in DFA. But here in epsilon mode, without taking any input symbol also, it can go to a different state using null. Okay, so null modes are allowed here. You can go to a different state by using a null move without consuming any input symbol. Okay. For example, silent, silent. A step by step, for example, it is that means what? This NFA can accept A, it can also accept B, and it can also accept any combinations of A and B. How? After reading A, it can take null move, it can read B, and again can take epsilon move and reach to the final state. Right? And if you want to accept only A, it can read A, then it will take epsilon move, then it can take another epsilon move and reach to which is the final state. The same thing here also. From here, if you want to read B, you can read another B, you can take epsilon and go to the Q state. So this type of moves are allowed here. Epsilon. Got the idea? For example, in sometimes what happens? Normally we know, right? For this input symbol, it is going to state Q1. For this input symbol, it is going to state Q2, and so on. But it is also possible that sometimes we are not sure which state to go. If we are just not sure after taking input symbol 1 or A or 0, whatever, where can or what is the next state. So if we are not sure what will be the next state, we can just go to any state with the help of epsilon. Okay. One real life example you can take is our vending machine. So what happens in vending machine? Suppose in the vending machine, the price for everything is like 3 rupees or 5 rupees or 2 rupees. Okay. For example, 5 rupees. 5 rupees you will get everything. So in the vending machine, if the user insert 5 rupee coins, suppose it's the initial state. So for vending machine, you can insert 5 rupee coin and you will get the item you want. Okay, so that's the process. Every time someone will insert a 5 rupee coin, you will get the item. That's the final state. Okay. Now sometimes it is also possible like maybe you don't have the 5 rupee coin. You might have 1 rupee coin. You might have this coin and so on. So suppose you just put to 1 rupee coin. Okay. Should the machine wait for it because it's not 5 yet, right? You inserted 1 coin and now doesn't know where to go. Means the condition is not satisfied, right? So maybe you are putting five 1 rupees coin. Okay, 5 times. So what you can do, 5 rupees coin, you put any number of time. 1 rupees coin, you can just insert any number of time, 1, 2, 3, 4, 5. So the moment you just insert 1 rupee coin, it will stay here only. You second time also you insert another 1 rupee coin, it will stay again here also. Towards the next state, we don't know that, right? So you can take an epsilon move and reach the final state. So you can complete 1 rupee coin 5 times and reach the final state. Okay. Or if you have 2 rupee coin and so on. Okay. So the real life scenario is like that. If you are not sure about the current state, you can just do the numbers and go to another state. Okay. Or you can also make, like, maybe you have more points. You can make 1 rupee coin, make epsilon, then you have 2 rupees coin, make epsilon. So I just assume you have just 1 and 2 rupee coin. And finally, reach. Okay. So machine will not halt, means it will halt until you complete the 5 rupees amount. Okay. So intermediate state, you can transit with the help of numbers. Is it clear? The use of epsilon. So as you know, we have the concept of null numbers. So with another part is that we can eliminate this null nodes. Okay, sometimes using null nodes can be like it makes the whole NF a bit complicated or maybe not easily understandable, even if it is easier to work. Okay, that means what? You can go to any state, you can take null node and reach to one state. You can move to means any number of states. Okay, using null nodes, but it sometimes make your NFA complicated as well. So next thing is we have another concept to eliminate null nodes. Okay, that means you can also say convert epsilon NFA to normal. Okay, this is another thing you have. Now, what are the steps? There are certain steps to do that. Okay, you can convert, means you can delete or eliminate null nodes with the help of certain state. So I'm just giving you the easiest steps. Okay, so just think it like you have two states, Q0 and Q1. Okay, just two states. You are just using an epsilon. Okay, You can also say this is S1 and this is S2. So what we have to do is that find all ages starting from Q1. Okay, you can also say state 2. That means what? You are going to consider all the null nodes between two states. So you have to consider it in a parallel. Okay, so you just find all the ages starting from Q1, that is the second state. Then you duplicate all those ages to Q0. Okay, I'm not telling you like it's an initial state. It can be any state. Okay, any normal state. Q0, or you can say state 1. Okay, without changing the labels. Labels. That means first, suppose you have Q0, Q1. So from Q1, maybe you have Q2 using 0. Okay, so what you have to do, you will just duplicate this age from Q1 from Q. That means you will make a path from Q0 to Q2 with the same length. Okay, so if there is any other paths or transitions from the state 2, you will duplicate all those ages starting from that second state, and you will make the same path from initial S1 state or Q0 state to the other state. Okay, so Q1 state, the outgoing age is with 0. So you will copy the same age and you will start from here, and now you can delete this part. Now you can delete this part. Okay. So third is now if state 1, or let's say Q0, is initial state, then you can make Q1 or state 2 as initial. So if Q1 was initial state, and after then you have to make the state 2 also initial after eliminating the null. Okay, and if state 2 or Q1 is final state, then make Q0 or state 1 5. Okay, now if your Q1 was the final state initially, then what you have to do? You have to make Q0 also final state. So if Q0 was initial state, you have to make Q1 as initial state. And if your Q1 was final state, you have to make the Q2 final state. We'll simply interchange. If it's so. If it's just normal state, then you don't need to do anything. Then another thing you can do, if there exists any dead state, what is the dead state? Means if it is not reachable from the initial state. If there is any dead state, you can just remove all dead states. Let's see an example. Let's see how we can pull it. Suppose we have this one. I will show you two examples. Okay. So what you have to do, what are the states? You can just think this is S1 and this is S2. There's only one null move. So what you have to do, first you copy all the states starting from Q1 and copy here. That means this will become Q0, Q1, Q1. Okay. From Q1, one edges go to Q2 from 1. That means you can copy 1 from Q0 and there is another for 0 it comes to Q0. So you can make moves here. So final will be, you can make 0 here and you will make an edge here. Okay. Now Q0 was the initial state. So after removing, you have to make Q1 also an initial state. That's it. This way you can remove the mask. Just copy the edges going out from the state 2 and make the same edge from Q1 or state 1. Is this one clear? Okay. So let's see another example of a difficult one. It is also possible that in the same NFA you might have multiple numbers of null moves. In this one, there was only one epsilon. It is also possible that there can be multiple numbers of epsilon moves, right? This one looks a bit complicated, I guess. So this is your NFA with two null moves. Now, in this case, you have to find out which epsilon to see first. First, you can just take any, you always have to consider it in a pair. You can either consider to delete the null move from here or you can also select from here. Okay, but there is a trick. If you select this second one first, then it will be more easier. Okay, so always select the null moves which has a next state for the there is a transition with input symbol from the next. Okay. If multiple epsilon modes are there, so select the one where there is no epsilon modes after that state. Okay. So if you consider, for example, this part, what is happening from Q1, again there is a epsilon. So it will be a bit difficult. So better choice is that you select a pair where in state 2, there is some transition with the help of different input supports. So first you consider this part. So here you can consider this one as 1 and this one as 2. State 1, state 2. So now you do the same process. What you have to do? You have to copy all the outgoing edges from state 2 from Q1. So what are the stages? There is a 0 going to Q5 from Q4. So you have to copy this here. Okay, and you can remove this part. So what will be the final stage? Q0, Q1. So what we did from Q4, this one will remain same. On Q1, we made a part with the help of input symbol 0. This one got removed and the rest will remain same. So in this statement, was it a final or initial state? Neither your Q1 was the initial state nor your Q4 state was a final state. So we don't need to do the step 3 and 4 because neither of them were initial or final state. So 1 is done. 1 null moves you have eliminated. Now you have this part. Okay. Now you can think again S1 is 2. So what you have to do? Same process from Q1. Which one is the outgoing? Which one is the outgoing? One is going to Q3. So you make the move with 0. Then another outgoing is to Q5. So you will copy this to Q5. Okay. There is one edge coming Q1 from Q1. So we are not going to consider that one. We only consider the edges going out from the state. Okay. Only outgoing edges, not incoming. So we will not consider this one. So from Q1, one part is going to Q5 using input alphabet 0. Another one is going to Q3 using alphabet 0. So you will just simply make the part from Q0 to Q3 using 0 and Q0 to Q5 using 0. Now you can remove this Epsilon part. Okay. So what will be the final one? Q0, Q1. So missing from here 0. From here condition 0. Okay. Now Q0 was an initial stage. That means what? You have to make Q1 also initial stage. Remember step 3, if state 1 is initial state, make state 2 initial. Okay. So state 1 was initial state, therefore we have to make Q1 also initial state. Okay. Now this is almost done. Now you say Q4 is a dead state. What is dead state? So Q4 state is not reachable from Q0 or Q1. Now we have two initial states, Q0 and Q1. And from both states, Q4 is not reachable. That means no edges to Q4 or by any means there is no connection to Q4 from Q0 or Q1, which are the initial state. That means we can remove this dead state. So even if we delete this dead state, it's not going to hamper your output. So after deleting this one, which one will be the final? Q1. This one. keep 5, keep this one will be cut, whole thing will be cut. Initial state from here now. We have 0 from here. Okay, that's the final NFA without any spelling. Is the process clear? If you have single ones, that is very easy. Just duplicate all the outgoing stage from state 2 to state 1. And if you have multiple lambda moves, you need to select it a bit carefully. Just select the one first for which there will be a condition using other alphabet from state 2. You can also select this pair first, then you start this part, but it is going to be a bit difficult. The easy method is there. Select the one pair where the next state will have some conditions with any inputs. Therefore, we have selected this part, state 1, state 2. This is the first pair we are considering. Then we are considering this second. The rest are just do it one by one. Is the process clear? Okay, very good. And if you find any dead state, you can just remove. So here Q0 was initial state, so we made Q1's initial state. But Q1 wasn't a final state. If Q1 would have been like a final state, then we would have to make Q0 as final state. For example, in this one, if there had been a null node, you have to make Q5 as final state because Q6 is the final state. You just follow these steps, the easiest way to do. Okay. Others clear? Chimao. Yeah, if you don't respond, I won't know whether you guys are understanding. Yes, has to.